Hi, my name is John.
And my name is Alice, and this is a math video for parents. We help you so that you can help your child. Today we're going to be going over division, and the way I learned it when I was in school was the standard algorithm for long division. So for this example problem, I'm going to say, first I'm going to look at how many times 14 goes into 36, and I'm going to say that's probably twice. 2 times 4 is 8. 2 times 1 is 2. I'm going to subtract. 16 minus 8 is 8. I'm going to bring the 7 down. Then I'm going to say 14 goes into 87. I'm going to try 6, see how that works out. 6 times 4 is 24. 6 times 1 is 1 plus the 2. Then I subtract. So my answer is 26 with a remainder of 3.
Great. So using the partial product method, which we've discussed in some of our earlier videos, we're basically taking the same problem, but breaking it down into smaller chunks, things that are easy to do by head. And by doing it in this way, we can make the problem a little bit easier if some of the numbers are too big to do mentally. So to show the problem solution through the partial product method, we still line things up the same way, but the first step and the steps that follow are a little bit different. So the first thing we want to think about is the number 14 here. That's our divisor. Perhaps how many times could 14 go into 367? So we know that 14 times 10 is something easy to do in our heads. That's equal to 140. So I can shave off 140 from 367, and that'll shrink my problem down a little bit. So I'm just going to keep track here that I divided by 10. I can repeat the process again. 14 goes into 227 a lot of times as well. So I will try once again 14 times 10, which I know is 140. I can take that off, and then I would be down to 87. So far, I've basically determined that 14 goes into 367 at least 20 times. I've already found that it goes in by 10 2 times. I don't think I can use 10 again because, as we know, 14 times 10 is 140. I don't have 140 to take away anymore. Now I'm down to 87. So I want to use, again, easy numbers to take off so I can trim this problem down to something more manageable. I happen to know that 14 times 5, another easy multiple, is 70. So I can shave 70 off of this problem, and now I'm down to 17. Last, 14 goes into 17 one time. So I will subtract a 14 off for the one time left. And now I'm in a place where 14 doesn't go into 3. The number that I have is less than 14. So there's no work to do here anymore. So what I've determined by this partial product method is that 14 goes into 367. If I add all these numbers up, a total of 10 plus 10 plus 5 plus 1, 26 times. And the remainder, after I find all groups of 14 that go into 367, I'm short by 3. So I say that the remainder is equal to 3.
So, John, this partial product method, what it reminds me of is when you're like cleaning out a garage or cleaning out your closet, and sometimes you have to get the big boxes out and the big objects out first before you can handle what's left. And that seems to be the approach with this technique. So let's try another problem, and I'm going to try to do it with the partial product method.
Sounds awesome.
Okay, so I'm going to say we're going to take 962 and we're going to divide it by 6. So using the partial products method, 6 by 100 is very easy to do in your head. That gives us 600. So I'm going to do that to start. And I'm just going to keep track over here what I'm doing. That's 100. So now I'm left with 362. I'm going to do 20 times 6. That's going to give me 120. $242. So I could do another 20 here. I already know what that is. Oh, interesting. I wasn't aggressive enough. I didn't take a big enough box out of the garage. I could do another 20.
Awesome. And I'm left with 2. So now I'm going to add all these up. This is everything I took out. That gives me 160. And I can't forget my remainder. I get a remainder of 2. Great. That's really cool. And what I like about it is there's no technically wrong way to do this. Like you said, you didn't take enough out. It's okay to not grab out, as much as one time as you can. You can break it up into smaller chunks that you know and understand and ultimately get to the correct answer.
Yeah, upon reflection, I might have tried to take out 50 after I did 100. So should I do this problem again with that approach?
Yeah, sure. Maybe we can do it on the same slide.
Sure. Let me get a different color. Okay. So let's say I'm going to do this over here. Let me start. So I'm going to recopy the problem. And I'm still going to start with 100. That worked out well for me. So I took out 100. And now I'm going to be a little more aggressive. I'm going to say, well, I know 6 times 50. That's easy to do in your head. I'll put it up here. It's going to be 300. And that leaves me with 62. So I'm going to say, well, 6 times 10 is 60, which leaves me with 2. So I get 160 with a remainder of 2. And I can see how once you do this, it becomes quite intuitive of kind of doing in your head what number is going to be too big and what number is going to be too small, so that you can do it in as few steps as possible if that's your goal. But again, either approach gives you the correct answer. So it's also a nice way to check your work.
Awesome. This was really interesting. And I think it also reflects the idea that with math, there's not always one right way to solve the problem. There's multiple ways that you could take to solve a problem. And this illustrates it perfectly. You can break it up in so many different ways. But as long as you get to the right result, we value the process sometimes over the result.
That's true in math and in life. In life, there's also many many paths to take to get to the right destination.
All right, awesome. So thank you very much. I hope this video was helpful, and we'll be back again soon with another installation of Math for Parents. Enjoy your day.